today I'm going to talk about how Lookout achieved continuous delivery. I'm going to kind of start with a little bit of history about where we were, and then talk about how we navigated the decisions around our implementation. And then towards the end, I'm going to talk a little bit about where we're kind of headed in the future. So yeah, a little bit about me. I'm Brandon. I manage platform engineering at Lookout. Been working in technology for about 15 years, and I've been at Lookout for 7. So first, a little bit about Lookout, right? We were founded with the mission of making the world more secure as it became more connected by mobile devices. Our main focus is mobile endpoint security, and we have a personal and enterprise product for Android and iOS, right? A little bit about our scale. Let's see, hold on a second here. We've registered over 100 million devices. We acquire and analyze about 90,000 mobile applications daily, right? We currently have about 100 services and about 2,500 EC2 instances. We utilize a lot of many AWS services like RDS, DynamoDB, Simple Workflow, etc. Pretty standard. First, a little history to give a little bit more context is Lookout's infrastructure was originally born in the data center. When we eventually had about 1,000 servers in 365 main. About 5 years ago, we started the process of migrating or launching services in AWS, and we kind of ran in a hybrid AWS data center model for a while. And 3 years ago, my team kicked off an effort to migrate us all to AWS, move everything to AWS, and we've since shut down our data center. So at Lookout, we've attempted and failed at achieving continuous delivery many times. Ever since I've been at Lookout, one of our biggest pain points has always been we need to speed up the deployment of features, services, bug fixes. When I first got there, we had a monolith, and we were doing weekly releases, right? Very painful weekly releases. Then we moved it to daily, right? And then we started trying to achieve continuous delivery. Coinciding with our move to AWS, we've struggled to build our own custom in-house CD tooling, right? And so I'd like to kind of, just for a moment, kind of take a look at some of those efforts. So, I spent a while trying to remember them all. Anybody here that worked at Lookout will recognize some of these names. Birds probably recognizes some of them. There is Chef Repo, CK1, Igniter, Blackbird. That was my attempt. Nix. It was funny. I was thinking about one of these teams the other day. I went to kind of check on and see how they were doing. I was like, "What are you guys doing?" They're like, "Well, we're building something like Terraform in Haskell." I was like, "Oh, wow, cool. Yeah, I'll check back in on you later." So we all these attempts were made by really smart people, right, with really good intentions. They all ultimately ended in failure. So let's take a closer look at some of these, right, and kind of the technologies they used, right. So we have Chef, Capistrano, Bado, Terraform, Docker, Ansible, Nix, Beanstalk. Maybe if we would have added Salt Stack and Puppet, we could have claimed we tried everything. I don't know. Some of these projects died without onboarding a single service, and others succeeded in onboarding significant portions of our infrastructure. So eventually, this is kind of like what we ended up at, right? 48% Blackbird, yeah, mine, yeah. 26% Chef Repo, 15% Nix, 10% Igniter, right? So we were left with fragmented deployment methodologies, which all were unsatisfactory and all fell short of our original continuous delivery goals. Almost all these tools were in some kind of state of being abandoned, and customers were frustrated and unsupported. There wasn't a clear path forward for net new services, and service owners were beginning to fragment further and explore their own, right? So the situation was kind of getting out of control, right? Our business simply needed to deliver features and services faster than our deployment tooling would allow us to. So our leadership decided to reboot the service delivery efforts and create a new, yet another dedicated team to solve this issue. I founded this team with the mission of of turning service delivery into a competitive advantage for Lookout, right? That was my mission statement, right? If we could deliver features and services faster than the competition, right, we'll win. So we call it SDP, which Spinnaker is a huge part of it, but I'm going to mention that many times in this presentation. It stands for Service Delivery Platform. So, before we started, we wanted to look at past efforts, kind of understand, try to understand why they failed, and what were we going to do different, right? What were we going to do different than all these other people did? So first we decided to treat SDP as an internal product. Previous attempts really had failed to engage their customers, right? They hadn't sought out their customers' feedback or experiences, to help guide direction. Rather than coming to our solutions with a solution that dictated their workflow, we spent time trying to understand what our customers wanted, their requirements, their pain points. We really spent a long time listening intently to their feedback until we were confident we understood how they viewed their situation, right? Another key thing is that we were not building a solution that we'd help service owners operate with them. We wanted to give them full autonomy. Another thing we did different is we used off-the-shelf tooling, right? Like I said, that all the past attempts had in common was glue code that tied together a bunch of different tools to craft a custom solution. We asked ourselves, we looked at all these things, we're like, would any of these things survive as an open source project? And the answer was no for all of them, right? So, instead we decided to follow the community and leverage industry standard tooling and not reinvent the wheel, right? And then finally, I think this is important, but it's maybe obvious, but I think it is important. We embraced iteration, right? Rather than going into the lab and coming out when we thought we had crafted a perfect end-to-end solution, we sought to get something in our customers' hands as quickly as possible and iterate based on their feedback. We embraced imperfection and tried to actually learn for them actually using our product. So we wanted to make sure we were solving the most important problems for our customers. We started by sending out a survey to all of our customers asking for their feedback, an internal survey. We got a lot of varied responses, but we were able to categorize and stack rank them here. So here's the results, right? Number one was unsupported non-standard deployment tooling, right? This is the most reported issue. Many of our customers' tooling was no longer supported internally or externally by a larger community. New service deployment is difficult, right? It simply took too much time and effort to launch new services. Duplication of infrastructure code. Creating and managing services often required copying around a bunch of boilerplate code everywhere. Deployments are manual and failure prone, right? There's too many manual steps in the deployments, which introduce the possibility of human error. This was often the root cause of many of our incidents, production incidents at Lookout. Access permissions and limits. This is really kind of a symptom of the larger problem. But it was people struggled with do I have the right IAM permissions to do what I need to do in AWS, right? We decided to just kind of remove their need to be able to reach and touch AWS APIs. It's if our engineers are having to actually do that, we're failing, right? CI instability, right? People thought Jenkins was slow. People thought it was unstable, which they're right. Secrets management, right? Our secrets management workflow had many manual steps, and it was very difficult to automate. And local test environments, right? Some engineers were really struggling to create reproducible, reliable development environments for their local services. So when we thought we had a good understanding of our customer requirements and pain points, we set out on building a POC, right, to see if we could solve some of these issues. So we had previously experimented with Spinnaker at Lookout, and I had experience using Asgard at a previous job, which is another Netflix service delivery tool. As we can see, Spinnaker's out-of-the-box functionality would solve many of our customers' pain points. So we decided, hey, look, we're gonna build this POC around Spinnaker. Here's some of the other factors that went into our decision, right? There's many companies supporting Spinnaker, right? On Netflix, obviously, right? But you have Google, Microsoft, Pivotal, Target, Veritas. Like all these companies have engineers they pay to work on Spinnaker. There's also many other companies that already had successful implementations, people that I knew, right, in the community, Adobe, Cloudera, Symantec, Twitch, Lithium, Reuters, GoGoAir. Like all these companies had successfully deployed Spinnaker and were using it in production. And so finally, some of our legacy tooling was actually set up in a way which would make a transition to immutable AMI deployments fairly easy. So once we decided to build our solution around Spinnaker, we were like, okay, how can we do this? How can we get this off the ground really fast? So we met Armory pretty soon after we made this decision. We were actually their first customer. This project had high visibility with executive sponsorship, and it was important to show quick progress. It wasn't like, look, you need to figure this out. It was like, you need to figure this out now, right? So, Armory helped us get off the ground really quickly and demonstrate value to our customers almost immediately. They came in, they set up, they operationalized Spinnaker in our environment. So my team could just focus on working with our initial customers. So Spinnaker didn't actually solve all of our problems, right? There are many other issues we had to navigate to deliver SDP 1.0, and I'm going to quickly go over some of these and how we solved them. I think I mentioned before, secrets was a huge pain point, right? We use Chef to manage secrets. This implementation had many problems, which I don't really need to go into detail, but suffice it to say, we needed to completely rethink how we were doing this. We ended up choosing Cerberus to solve this issue. I actually encountered Nike Cerberus at reInvent 2016 when Nike announced it. Had a lot of features we liked, right? First, it was open source. We've been in contact with the Nike team, and they're super useful and super helpful. So that was a big plus. It's secure. I like the security model. It stores encrypted secrets and provides role-based authorization based on IAM roles, which is really nice. It's easy to use and self-service. It allows our customers to manage their secrets themselves with a self-service UI, and it has Okta integration for authorization. It's fault tolerant, right? It's architected, has tons of self-healing components, and robust automated backups. So yeah, we've been really happy with Cerberus and really have enjoyed working with the Nike team as well. So service discovery. When we started this project, service discovery at Lookout was complicated and cumbersome, which is actually my fault because I built it a couple of years previous, right? So service discovery was done with a console HA proxy configuration, right, which was tightly coupled to Chef cookbooks and a lot of in-house built libraries. We decided to just greatly simplify service discovery and just went with DNS naming conventions, right? Which, when someone mentioned this pattern to me, I was like, wow, that's really obvious. Why? It fits nicely with Spinnaker, right? Because ELB health check becomes a source of truth about everything. It fits the blue-green or red-black deployment model, Spinnaker, right? So if you wanted to talk to Service A in staging, you would just say servicea.staging.yourdomain.com. Although this this was a simplification, later in the migration, it caused us some complications because if you moved one service to Spinnaker, you had to go change all the client services, right, that talk to that to use the new service discovery. So application configuration, right? All of our application configuration, in almost all cases, was managed with Chef. Initially, we tried to keep Chef for our application and middleware configuration. Each service would converge Chef code, which would pull in the service artifact, and then Packer would bake an AMI to be used by Spinnaker. But this ended up being cumbersome and failure prone. I think Armory was like, you guys are crazy. I remember Isaac being like, why are you doing this? So we ended up moving away from Chef entirely, right? We moved to environment-specific application moved all the environment-specific application configuration into the service repos themselves, and used a great old plugin called Nebula, which is actually a Netflix tool, to build and manage Debian packages. Each package contained the service artifact and its dependency, right? This enabled us to store all the application code and OS middleware configuration in the same repo, and greatly simplified our AMI bake step. So since we were building this new platform, we wanted to build a new way to measure and report its availability as well. So, we created this tool called Slayer. And Slayer was a simple service we built, which was basically a wrapper around the Datadog agent. It allows you to create services and define checks, which then are used to calculate that service's SLA. Then it creates the Datadog dashboard and SLA calculations for each service or product, right? So, here you can kind of see what the output of Slayer is. If we say GitHub's up, if Slayer can log in, clone a repo, and push a commit, right? Artifactory's up if you can log in, push artifacts, download artifacts, et cetera. I mean, my real goal here was just to provide transparency to our customers about our availability and stability. We initially had work to actually expand Slayer and rewrite it and open it up to all service teams at Lookout. But it doesn't actually seem like that's going to happen anymore. One of the engineers on one of my teams, Bruno, at one of our hackathons created something called SLAP, and I think that's going to end up replacing Slayer. But, yeah. So yeah, this is kind of like what our first implementation of SDP 1.0 looked like, right? Any push to Git triggers a Jenkins job, which creates a Debian artifact, pushes it to Artifactory. At the end of your job, your Spinnaker pipeline is updated and triggered, right? All pretty standard. So here was our timeline for the project, right? By mid-November 2016, we'd identified a POC service, and we aimed to have it fully deployed by Spinnaker on December 30th, right? We were able to hit that date, so we had one service in production. After completion of our POC, we moved on to a beta phase, right? And our goal with beta was to onboard 5 more services and have an initial draft of our onboarding guide. On February 28th, we actually hit that milestone, and we had 5 services deployed to production with Spinnaker. After beta, we took a step back and kind of took some time to kind of process what we had learned, and set out on the goal of being able to go for general availability, where we support 80% of services at Lookout. And the 80% of services was actually important because there was a lot of services at Lookout that had some really weird technologies and some really weird requirements. And I just kind of decided well, we're not going to try to support those services initially, right? We're going to try to help the greater good. And it's funny because someone said, well, what percentage of the services will you support? And I said 80. And then when I actually did the calculation, it was 81.3, so my guesstimate was pretty good. After we completed beta, we gathered some metrics on before and after Spinnaker, right? We evaluated 5 success metrics. First was steps to deploy went from 25 to 1. 3 depending on the pipeline design, I guess. So this is the number of manual steps it takes, including validation, to deploy a service through all staging environments to production. Each manual step, again, kind of introduces the potential for human error, and which was responsible for many of our deployment failures and service outages at Lookout. Engineering time to deploy went from 60 minutes to less than a minute, right? And this is the amount of time it takes on average for an engineer to deploy from staging to production, through staging to production. This represents a massive increase in engineering productivity. Automation time to deploy, this is just the amount of time it takes to deploy, regardless of the engineer, went from 60 minutes to 31 minutes. And finally, onboarding time went from 3+ days to 30 minutes, right? And this is the amount of time it takes for a new engineer to be comfortable deploying code to production. So these metrics, showed a very significant increase in engineering efficiency, and the order was given move all services to Spinnaker now, right? That was kind of came down from on high. So this migration effort of moving all services was pretty enlightening. We learned a lot during this process, and I'm going to go over some of the things we learned. So like, yeah, CD, continuous delivery is a people problem as much as it is a technology problem. We quickly realized that some of our customers didn't understand CD principles and concepts, or even if some did understand them, they didn't see value in them. They didn't understand why they should adopt this new, adopt continuous delivery. The CD workflow is very different from manual or traditional deployment methodologies, and it's really important that service owners understand these differences before they move to Spinnaker. So yeah, we kind of took a top-down approach, right? We started by getting buy-in from our chief development officer and her direct staff. And then we moved to a meeting with all engineering managers where I was like, and where they had, like, she had a slide in the presentation, right? So it was her actually giving part of the presentation. And then from there, we set up, after we did out of engineering, all engineering managers, we went all directly to engineering. I mean, basically we ran like a little internal marketing campaign, right? Once we had everybody on the same page about where we were headed, and there was like a shared vision about where we wanted to be, things went a lot smoother. One thing we also did is, we picked key influential leaders and like high visibility services to be our initial customers, right, to demonstrate success. I mean, I guess this is obvious. I don't know, but all the previous attempts had really failed at this, but it was very important for us to build alliances and partnerships with all of our customers to be able to execute this migration. So like land and expand, this is actually a new term that I learned from our CEO. He talks about it like relative to like SaaS sales, but I think it's relative to what we did, or it describes what we did as well. We had about 20 engineering teams and roughly 120 engineers and about 100 services to migrate. And CD team was like 5 people, right? So, we'd already implemented end-to-end service ownership, right, at Lookout, right? So we needed to figure out how to support service owners' effort to migrate their own services. This was not something that we were going to do for them, right? And it was interesting, too, because our chief development officer, again, made this the #1 internal engineering priority, right? So this was like, this trumped everything else on our internal roadmap. So how do we prepare ourselves for this like stampeding herd of people, right, that are going to start trying to onboard? There's a steep learning curve to cloud technologies in general. The immutable model's kind of difficult for people to wrap their head around. Like I had one guy being like, "Why are you deleting my servers? I don't want them deleted," right? Like where are they going, right? So it's like, so there's a lot of education that needed to go on, right? So the learning curve was pretty steep for some teams, right? But we knew that like once we had, like if we could get one engineer in every team that knew how to do it, we could just get him initially, like get him to onboard a service, then he could help his other team members, right? So this is, I guess, a little bit obvious, but this is kind of how we set it up, right? We're like, these initial 2 sprints, we would only support 4 services per sprint, but we were really strategic about the people that we picked and made sure that we had it distributed across key people in all the teams. And then it kept expanding sprint over sprint. And this really kind of allowed us to be strategic about knowledge propagation across all the teams. So, I mean, I guess this is kind of obvious too, but the CD team did a really good job of keeping track of all internal customer requests for the onboarding process. And we constantly asked ourselves, we reviewed them every week, and we're like, how could this customer request be automated or made self-service? So this whole process actually paid off and reap a lot of results later, because as we improved this, engineers were able to like onboard about 5 times faster than they were when they started. So we spent the last 4 quarters working on migrating all services at Lookout to Spinnaker, right? It's been a organizational-wide effort. It's finally coming to a close. I think there are about 5 out of 100 which are still needed to migrate to Spinnaker. And it was funny because I was in quarterly planning, and like I realized those 5 weren't going to make it, and I was like, man, I'm going to have to go to the Spinnaker summit. And I was, my abstract says we've already moved all services. Don't make a liar out of me. But yeah, there's about 5 left. It's been a lot of work and significant investment, right? But as we started to get a critical mass of services in Spinnaker, we started to see a lot of results. And in one of our all-hands not that long ago, a couple weeks ago, our CEO asked, like, why is engineering, like, developing, or, like, their velocity of delivering new services and features is, like, you know, off the charts, what's going on, right? So this is a little snippet from a quarterly retro that our Chief Development Officer just gave to engineering. And the first reason for this increase in service velocity was the adoption of SDP. I mean, to be clear, it wasn't the only reason, but it was one of the main reasons, right? Engineers were like simply happier, more productive. They were like spending less time dealing with code deployments and more time creating value for the company, right? So like victory, right? You know, and I mean, in a certain way it was, right? It was pretty satisfying. You know, we had taken a weakness at Lookout and turned it into a strength, right? We'd solved the service delivery problem, and we led the organization through a massive change that greatly increased productivity, right? But this is really just kind of only the beginning, right? Because now that we have everybody on the same platform, we can build new capabilities and offer them to our customers in a very highly leveraged fashion. So I like to think of SDP as like a paved highway that gets our customers from where they need to go, gets them where they need to go, like quickly and safely. You know, now we can add a new capability to the platform, and since everybody's on the same platform, everybody gets it for free, right? So we've been using the platform, leveraging the platform to deliver new features which increase cost efficiency, developer productivity, and security of our services. So now I'm going to switch gears a little bit and talk about the new capabilities that we've been able to offer our customers who have adopted Spinnaker. So one-click project creation. You remember, like in the customer survey we did earlier, one of the main pain points that people called out was that it took too long to create new services, right? Like literally, like some people were like saying, I allocate 2 weeks, right, to launch a new service, right? That's not development time. That's just like getting it in staging and production, right? I mean, like many companies, Lookout's age and size, we've had to overcome a significant amount of tech debt. Much of this tech debt is in the form of like legacy monolithic services, which were difficult and costly to maintain. Lookout has spent a significant resources to eliminate this tech debt by replacing these monolithic services with microservice architecture. But what if in replacing these large monolithic piles of tech debt, you replace them with a multitude of services that all have their own little snowflake implementation, right? This is a type of tech debt in and of itself. Even though these microservices will say all be deployed with Spinnaker, we wanted to ensure that all other aspects of them were unified as well. Yeah, so and another pattern that we saw before is that, if there's significant friction to creating new services, teams are more likely to add new features to an existing service, right? Like, well, I'll just add this API to another service. That maybe that's not the best architecture, right? And so you start getting this like little mini monoliths like sprouting up again. Yeah. So to solve this problem, my team built a service called One-Click Project. With One-Click, customers are able to create a new service and have it deployed to production in about 10 minutes. So with One-Click, you get a service that incorporates all the best practices and Lookout SDP capabilities. So like here's a screenshot. First time we built this, we actually built it with a a web application, but we were like, hey, actually, this should just be a Jenkins job. So here's a screenshot of the Jenkins job. As you can see, you just specify the service name, the product team tag, select the framework you want. Like in our case, we've standardized on Java and Scala for the Play framework. The GitHub org, whether or not you want to use Garrett or GitHub for code reviews. And in about 10 minutes, you have a Hello World service deployed all the way to staging. It creates your Git repository from a template. Creates your CI and build jobs. And it creates your Spinnaker pipeline and deploys your Hello World service all the way to staging. You can see the pipeline there is like stopped at staging, right? So we have a manual judgment. If you just click the manual judgment, your Hello World service will be deployed to production. And all engineers have to do, our customers have to do now is start committing code to master, and it's continuously deployed. So containers. A lot of people ask me why we didn't start containerizing our services initially when we started migrating to Spinnaker, right? And I think it's a really good question. We actually considered it, discussed it a lot. One of the main reasons was that all of our security and compliance tools were built to work with VMs, and they needed to be updated to work with containers, right? So we didn't want that development or fixing that to stop our implementation of continuous delivery, right? Now we're addressing that problem, and we're working on adding a containers capability to SDP. So with containers, we're looking to increase developer productivity by speeding up pipeline execution times, right? As well as, you remember that survey of like, hey, I don't have a real good way of doing local development environments. I always kind of knew in the back of my mind that, like, well, we're going to solve that problem when we, or be able to offer a story around that when we move to containers, right? And like, containers also puts us on the path to cost optimization with faster auto-scaling, resource utilization. I'm sure all of you know this, but yeah. So Lookout's completely in AWS. So we began to evaluate, like, okay, what are we going to do for our container orchestration? Are we going to use Kubernetes? We're going to use Amazon's ECS. I think that this decision analysis could be its own presentation, but I'll just kind of go into some of the factors that went into our decision. So we were in an interesting position, right? Because like Kubernetes already had a Spinnaker driver, right? ECS did not, right? And the Kubernetes driver was battle tested and stable. The downside at that time was that we would have to run Kubernetes on EC2. So the fundamental decision came down for us is, do I want to build a team to manage Kubernetes, or do I want to build a cloud driver for ECS, right? Yeah, so there's also some other things that ECS has very tight integrations with all the rest of the AWS ecosystem. It's funny because like right when I was actually in Mexico scuba diving, and my boss called me and was like, Amazon just joined the Cloud Native Foundation, right? And I was like, oh, they're building a hosted Kubernetes, right? And like, so I got we called them, and we got the guy who runs product for ECS on the phone, right? And kind of like went over this decision with him. His take on it was actually pretty interesting. But anyways, in the end, we decided that we'd rather build an ECS cloud driver, like I said, than build a team to manage Kubernetes. I announced that we're going to build this at the last Spinnaker Summit, and we've since released this ECS cloud driver to the community. This was also the CD team's first big contribution to the Spinnaker community. We're closely watching the evolution of EKS, and I think it'll be very interesting to see how this decision plays out over the next year. Canaries, right? So once we had implemented continuous delivery, we kind of set our eyes on continuous deployment. Like how are we going to achieve that, right? We knew that one key component of that would be metric-based canaries. We'd been talking with Armory from the get-go about like how this is a capability we wanted, and we had heard all the stories about how Netflix had implemented this with great success. So, I mean, Armory actually really kind of stepped up with us here and was like, okay, let's solve this problem together, right? So they put together a hackathon where Lookout is the customer and Armory came together and tried to solve this problem. We brought our services, our use cases, requirements, and laid the foundation for an automated metric-based Canary platform in Spinnaker. The initial outcome of this was Armory Barometer. Armory Barometer is a service that integrates with Spinnaker. It'll take time series data and do metric-based deployments based on your time series data, which in our case is like Datadog. So yeah, you can see how this works in a little bit more detail, but the way we had it implemented is basically if you had release A or release 1, it would take 2 more server groups of release 1 and one of release 2, tag the metrics that were going into Datadog, and look for deviation in the 2 metrics. So yeah. So yeah, you can configure your Canary to watch any system or application-based metrics. Here you can see we're looking at response codes, other application metrics, system-level metrics. And here's a pipeline where the Canary has succeeded and one where it has failed. And if you'll see down there, one of the features I really liked about it is that it created a Datadog dashboard that showed you all the metrics that failed your Canary, which is actually really useful. And I mean, obviously, one more note is that Barometer filled a need for us for a while. But Google and Netflix, I think it's pretty well known. They collaborated, sharing their knowledge about metric-based Canaries and built a platform called Kayanta, which is now the future of this. And so we're in the process of moving all of our stuff off Barometer and into Kayanta. But I will say it is one of the coolest things about using Spinnaker as CD platform is that you can leverage contributions from people like Google and Netflix and start, you can leverage all their contributions.